Hello dear friends, myself Sunil Sonigra, and today in the subject of mechanical drafting we are going to discuss chapters based on intersection and penetration of solids and surfaces. We know there are four types of basic solids that we have to study, that is prism, pyramid, cylinder and cone. And today in present discussion we will cover the intersection and penetration of two solids, namely cylinder and cone. And today's discussion covers to understand the concept of intersection and penetration of solids and surfaces, and to solve the examples based on intersection of cone and cylinder. These are today's objectives for discussion. Now first, what is intersection? When two solids are to be joined together, the curve of intersection is required to be drawn to decide the shape in which two solids should be cut. That is called as intersection. This concept is widely used in fabrication industries to join two objects like pipes, conical shaped objects, drums, etc. This is one example which includes the application of intersection of solid and development of surfaces. This is the combination of cylinder and cone. The intersection of two solid surfaces results in the formation of a line of intersection at the joint where the solids intersect or penetrates. The line of intersection is known as transition line. This is one intersection of cone and a square prism. The types of lines of intersection are straight lines, curved lines, and combination of straight and curved lines. If both the solids are having straight edges and plane surfaces, then the intersection line would be straight lines, but in the case of cylinder and cone, the curvature line would be there. So it may be combination of curved line and straight lines. In solids, this is the first solid, that is cone, which is having four parameters, that is vertex at the top. This top tip is called as vertex, height is altitude, this is base, and outer surface is lateral surface. In case of cylinders, it is having two parameters, its height and diameter, and this shows intersection of two cylinders, vertical cylinder and horizontal cylinder. This diagram represents intersection of cylinder and cone. Cone is in a standing position and it is penetrated by a cylinder. So in this case, the cylinder is called as a penetrating body and cone is called penetrated solid or standing solid. So in this case we can say the cone is penetrated by a horizontal cylinder. This is also the same case, cone is penetrated by a horizontal cylinder. Now whenever two or more solids combine, a definite curve is seen at their intersection. This curve is called the curve of intersection, or it is called as COI. This is the example of intersection of solids. You can see here, this is the intersection of two cylinders. This one shows intersection of vertical cylinder and horizontal cylinder, and this shape or this curve is the curve of intersection. This is intersection of two cylinders at right angle, and this is intersection of two cylinders of equal diameter. In this case, a cross line would be there to show the curves of intersection. Industrial application of intersection of solids. In industry, these are the pipes are to be joined, and the variation in shape will cause the intersection of solids application. This is one problem, the intersection of cone and cylinder. Vertical cone is there, horizontal cylinder is there, and this curve that we have to draw, and that is the objective for today's discussion. In front view, this curve would appear as shown over here, and in top view this curve would appear as represented over here. This is one more example of intersection of cylinder and cone and prism and cylinder. a square prism and cylinder are intersecting each other, or cylinder is intersecting the square prism, so it could be the case. This is one more case, intersection of two cylinders, intersection of hexagonal prism and cylinder, and this is hexagonal prism and cylinder, and this would be its front view or side view, depends upon the viewing side. Now first example, based on this discussion, the first example, a cone base diameter 60 mm, height 70 mm is resting on its base. It is completely penetrated by a horizontal cylinder of 80 mm length and has its axis parallel to VP and intersecting the axis of the cone 25 mm above the base. Draw the projections of the solid showing curves of intersection if the size of the cylinder is such that its projection in the side view is the circle touching the generators of the cone that represent the true lengths. So here the data is given like this. Steps for thinking: cone is given of diameter 60 and height 70 mm, base is on ground, so its top view and front view. Top view would be circle, front view would be triangle. A horizontal cylinder axis 25 mm above XY line is given. So after drawing the cone of given dimension, we have to locate the axis of horizontal cylinder, which is 25 mm above XY line. It is given in the data. The cylinder is 80 mm long and diameter to be found from side view. The diameter of the cylinder that we can find from the side view, because it is given that the cylinder touches the true length of the cone. So diameter is not given, but that we have to find from its side view. Take projection from side view to other views, and then after we can draw the problem. This is the solution of the problem. First we draw XY line, which represents the intersection of HP and VP, and it's a cone, so its top view would be a circle having diameter given as 60 mm. So first step is to draw a circle below XY line of given diameter. After that, draw a meter line to draw its side view and locate its axis. Draw horizontal line from its apex point, this point, and when it cuts this meter line, from that draw a vertical line, and this is called as the axis of this cone or center line of the cone. Then height of this cone is given, that is 70 mm. So at a distance of 70 mm from XY line, mark a point on this axis somewhere here. So this is the apex point of this cone. Now draw a triangle in such a way that its height is equal to 70 mm, apex point is this point, and width is equal to the diameter of this circle, or we can take projection from these two ends of this circle. Then draw its front view. In front view also it would appear as a triangle with height 70 mm and width is equal to the diameter of this circle, that is 60 mm. So these are the three views of this given problem. Now locate the apex point O double dash of this cone. Now it is given that the axis of horizontal cylinder is 25 mm above XY line. So above XY line, somewhere here at a distance of 25 mm, mark a line or axis. So this is the center line for the circle or for the cylinder above XY line at a distance of 25 mm on this axis. So this is the point of center of the cylinder. So taking this point as a center, we have to draw a cylinder, but the cylinder should be drawn in such a way that it touches these two edges. These two are the true length of this cone, so it should touch these two edges. So how to draw that circle? So for that, draw this point, a line from this point to this line in such a way that this angle becomes 90 degree, or this line is right angle to this slant edge, this true length. So this angle is 90 degree. After that, take this center point as a center and this point to this point as a radius. Draw a circle like this. So this is the side view of given cylinder, and from this we can find out the diameter of this cylinder. Now take projection from this side view and draw its front view by drawing horizontal lines from here, and similarly these two edges will be inside the cone, hence it will not be visible, hence that those edges, upper edge and lower edge, are to be represented by the dotted line as shown over here. Now after drawing this dotted line, let me draw the top view of this cylinder. So for that, draw meter lines, draw projection line from this side view to the meter lines like this. From that, draw horizontal lines, and width or length of the cylinder is given to us. So according to that length, mark the 2 points and 2 vertical lines over here. So this is the top view of the cylinder. After drawing this top view, let me decide the visibility of lines and edges. This portion is below this cylinder. So in this portion, the cylinder bottom edge will not be visible. Hence this edge to be drawn by the dotted line. This will be full line. So this is the dotted line because it is below the cylinder. So this edge would not be visible, to be represented by the dotted line. Similarly on this side also, this curve would be the dotted line. Now next step. Now we have drawn 3 views of given solids, cylinder and cone. Now we have to find out the points of intersection of these two solids. So for that, let me discuss first step, how to find out the points of intersection. So for that, first we draw a line or imaginary generator over this cone from this apex point. Line from this apex point, this is an imaginary generator drawn over this outside periphery of this cone, and draw 3 views of this generator. So for that, what should we do? Take projection from here, draw vertical line from here, and then draw horizontal line from here. It will cut this circle at this point, join this point with this center or apex point of this cone. Similarly, this is the top view of this generator. Now draw front view of this generator. So for that, draw vertical line from this generator from here to here and join this point with this apex point. So this is the generator, this generator, right? Now similarly we can draw more generators like this. Vertical line from here, slant line from this apex point to here, transfer this point to the meter line, from meter line transfer this point to top view where it cuts this cylinder at this circle at this point, join to the midpoint of the circle somewhere here, transfer this point to front view, and this is the front view of this generator. Now one more generator over here, draw line from this apex point like this, transfer to meter line, from meter line to the circle, it will cut this circle at this point, join that point with the apex point or center of the circle. From here, draw vertical line, it will cut this base at this point and join this point to this apex point. So this is the representation of these generators in front view. Now one more generator, this end point, draw vertical line from here, horizontal line from here, it will cut this circle over here. From that point, draw vertical line, transfer to this side, to this front view, and this is the generator. Now we have to find out other points of intersection. So for that, let me think about this cylinder, this cone, this circle. Find out points of intersection between this circle and this cone. So let me pick up this point. Here is one point that shows the intersection of this slant edge and the circle. This is the point. So from that point, draw a horizontal line, and that will cut this generator at this point. Why we taken this point as an intersection point? Because this point is on this generator. So think about the top view of this generator and front view of this generator. The top view of this generator is this one and front view of this generator is this one. So from this point to the front view of this generator, draw horizontal line. It will cut that generator over here. Now second point is somewhere here, intersection of this imaginary generator and this cylinder is this point. So from this point, draw horizontal line. It will cut the generator at this point. So this generator is this one, this one, this one and this one. So on this generator, mark a point over here. Similarly, one point is here. So from that point, draw horizontal line. It will cut this generator over here. So we have picked up 3 points. Similarly, more points to be found from here. From this point, draw horizontal line. It will cut this generator over here. From this point, draw horizontal line. That will cut this generator over here. So these are the points. Similarly, the end point, this one, it would be here, and join all these points with a smooth curve. But here, if we join with the smooth curve, all the points will come on the straight line. So alternatively, we can join all these points with the straight line as well, because here this circle touches the edges or true length of this cone. Hence here straight lines are there. Otherwise it would be smooth curve. Now the same steps should be repeated to draw on this side the same curve. So the steps, I am not repeating those steps, just I am drawing all these straight lines as shown over here. So this is just the mirror of these points. Now think about its top view. How to draw its top view? Now what is about these edges? This edge will not be visible, this one, because it is inside the cylinder. So it should be removed. Erase that edge because it is a cut portion. Similarly, this edge is also not visible. So erase that edge also. Now this straight line would be fully visible line. Now to find out the top view of this intersection, let me pick up this point. From this point, draw straight vertical line. It will cut this generator at this point. This generator is this one at this point. Similarly, from this point,